All right, so we've got our directional derivative, the direction of the unit vector u is the gradient times dotted with the unit vector. Okay? Now, from previous discussion, the geometric interpretation discussion of what the dot product is, the dot product is also equal to, if you've got theta is the angle between the two vectors, then the dot product is equal to the magnitude of the two vectors multiplied together times the cosine. Yes. Theta is the angle between the two vectors. Okay? Now, what's the magnitude of this? It's a unit vector, and so what's the magnitude? What's the length? It's 1, right? Yeah. Since u is a unit vector, its magnitude is 1 by design. And so the directional derivative then is just the magnitude of the gradient times the cosine of the angle between. Okay, now, one aspect to that, or one thing we can get at looking at it in that particular way, is a maximum value. When would we have a maximum value for this directional derivative? Well, the maximum is going to occur when the cosine is at its maximum, which the maximum of cosine is 1, right? And so the maximum here of this directional derivative going to be when cosine of theta is 1. Now, what does that mean? When is the cosine 1? Theta is 0. 0 degrees, 0 radians. So the angle between, so that means the angle between these two vectors is 0. So in other words, the unit vector is going in the direction of the gradient vector, or vice versa. But specifically, the maximum is going to occur when the unit vector is in the exact direction as your gradient, because the angle between them is 0. Okay? So the maximum directional derivative here is when the direction you're going is the same as the gradient direction. Okay? Now, what this also means is that the maximum derivative is going to be, if this is 1, if that's the maximum you can have there, then the maximum value of the directional derivative is what? Well, if the maximum here occurs at 1, if that's 1, then what is the directional derivative? It's just the gradient magnitude. So your maximum derivative is the magnitude of the gradient vector. Okay? That's as big as the derivative can get. The magnitude of the gradient vector. which means a lot of different things. Your derivative is your rate of change, and so that's the maximum rate of change you can have for any particular function. If it's differentiable, it's the magnitude of the gradient. Okay? So, with that in mind then, let's see. Find the maximum rate of change of f of xy equals x e to the x at 1, 2, and the direction of the maximum rate of change. Okay. Well, what we saw was the maximum is going to be the magnitude of the gradient. And so the gradient is what? It's partial of f with respect to x, partial f with respect to y. All right, so what is that here? Partial with respect to x, so we've got a product. Need a little product rule there. First times the derivative of the second. Well, it's e to the xy, so it'll be e to the xy times the derivative of the power with respect to x, so it'll be y, plus, oops, better do my other part, e to the xy times the derivative of x, which is 1. All right, then the partial of f with respect to y, well, it's just, that's not a product rule, that's just, so it'll be x times e to the xy times the derivative with respect to y of the power, so that's just x. Yeah, so it'll be x squared. So we've got xy, e to the xy, plus e to the xy, comma, x squared, e to the xy. So that gradient at 1, 2 would be what? X times y, so it would be 2 e squared plus e squared. Be the first part of it. Do that right? 3e squared. And then the other one would be 1 squared times e to the, so it would be e squared. So yeah, 3e squared, comma e squared would be the gradient at 1, 2. And so the maximum then rate of change, or maximum derivative, if you will, maximum rate of change, maximum of our directional derivative here, just be the magnitude of our gradient. So what would that be? It'll be the maximum, be the magnitude of that, so it'll be the square root of each one of those squared added together, some of those. So 3e squared squared plus e squared squared. So it'll be the square root of 9e to the 4th plus e to the 4th. Square root of 10e to the 4th. Which would be the square root of 10 times e squared. Okay. So that would be the maximum rate of change that this particular function would have at 1, 2 anyway. Square root of 10 e squared. And then the direction, what would be the direction? They may want it in terms of a unit vector. So what would be the unit vector? Yeah, so you take the gradient vector and divide it by the magnitude. So what, all right, so it'd be 3e squared. E squared, divide that by the square root of 10, e squared is probably how they would want us to do that. 3 over square root of 10, comma, 1 over square root of 10, right? So that would be the direction of this maximum rate of change.